We are starting with the formula list that is required for the chapter of ITF. Okay, so trigonometric functions and inverse trigonometric functions, the formula list for both the chapters is very important, not only for this particular chapter, but then also for the remaining chapters which are there in the syllabus. Okay, so we'll take some basic formulae which are there in trigonometric functions. Obviously, the fundamental identities coming to the picture at the first moment. Okay, so the fundamental identities are sine square x plus cos square x is equal to 1, sec square x is equal to 1 plus tan square x, cosec square x is equal to 1 plus cot square x. Okay, then sine of minus x is minus sine x, cos of minus x is cos x, and tan of minus x is minus tan x. Fine. Next, some standard values. Theta, that is 30, 0, 30, 45, 60, 90, and one more I'll include, that is 180. These are in degrees. Okay, so sine theta, cos theta. 0, half, 1 by root 2, root 3 by 2, 1 and 0. 1, root 3 by 2, 1 by root 2, half, 0 and minus 1. Okay. Remaining values you can very easily calculate because you know the relation between the remaining trigonometric functions and sine and cos. Okay, so I can say in this way, sine theta is equal to 1 upon cosec theta and cosec theta is equal to 1 upon sine theta, right? Then cos theta is equal to 1 upon sec theta and sec theta is equal to 1 upon cos theta. So if you want to find out the value of sec, then it's the reciprocal of cos. So it's enough for us to find out the values of sine and cos, for us to remember the values of sine and cos. Remaining values you can, just calculate using this reciprocal trigonometric functions. Then tan theta is equal to 1 upon cot theta, or it is also sine theta upon cos theta. And then cot theta is 1 upon tan theta, which is cos theta upon sine theta. This you are very well aware of. Okay. Then to convert degrees to radians, we multiply by pi by 180. And to convert radians to degrees, we multiply by 180 by pi. Okay. Yeah. Then let us understand, or rather, let us write compound angle formulae, which was there in the earlier grade. Sine A plus B, which is sine A cos B plus cos A sin B, sin A minus B, sin A cos B minus cos A sin B, cos A plus B is equal to cos A cos B minus sin A sin B, cos A minus B is equal to cos A cos B plus sin A sin B. Okay. Two more compound angle formulae. Tan A plus B, tan A plus tan B, 1 minus tan A tan B, and tan A minus B is equal to tan A minus tan B, 1 plus tan A tan B. Okay. Then we have factorization and defactorization formulae. So I'll just write down the factorization formulae. Sin C plus sin D 2 sin c plus d by 2, cos c minus d by 2, sin c minus sin d, 2 cos c plus d by 2, sin c minus d by 2, cos c plus cos d, 2 cos c plus d by 2, cos c minus d by 2, and cos c minus cos d, 2 sin c plus d by 2, sin d minus c by 2. Okay. Recording. So naturally we'll try and understand the defactorization formula later on. Okay. Defactorization is the opposite of factorization. 2 sin A cos B, 2 cos A sin B, 2 cos A cos B, 2 sin A sin B. So this is sin plus sin minus sin, cos plus cos minus cos. So A plus B, A minus B, A plus B, A minus B, A plus B, A minus B, and then this is A minus B, and this is A plus B. Defactorization formula. Okay. Next, the double angle formula or the half angle formula. It's a long list. Sin 2x is 2 sin x cos x. Sin 2x is 2 tan x upon 1 plus tan square x. Okay. Cos 2x is 2 cos square x minus 1, or 1 minus 2 sin square x, or cos 2x is cos square x minus sin square x, or cos 2x is equal to 1 minus tan square x, 1 plus tan square x. Okay. So in the entire half angle or double angle formula, if it is 2x over here, it will be x over here. Okay. So half of whatever it is there on the left hand side. Okay. And if you take a look reverse way, okay, it will be double. So x will be 2x from right to left, and from left to right it is half. Okay. At the same time, if it is 4x over here, if it is 4x over here, the right hand side will be 2x. So half of 4x is 2x. That's the nature of half angle double angle. Tan 2x, 2 tan x upon 1 minus tan square x, then 1 plus cos 2x, 2 cos square x, 1 minus cos 2x, 2 sin square x, 1 plus sin 2x, cos x plus sin x the whole square, 1 minus sin 2x, cos x minus sin x the whole square. Okay. So this completes the list of half angle, double angle. We'll go to triple angle formula. Sin 3x, 3 sin x minus 4 sin cube x, cos 3x, 4 cos cube x minus 3 cos x, tan 3x, 3 tan x minus tan cube x upon 1 minus 3 tan square x. This is tan 3x. Okay. So this is the triple angle formula that you need to remember. Now this completes the entire formula list for uh, trigonometric functions. Now let us understand the nature of ITF, that is inverse trigonometric functions. Sine 45 is equal to 1 by root 2. Okay, now if you take sine on the other side, okay, so 45 degrees is equal to sine inverse of 1 by root 2. So 1 by root 2 is the value of the trigonometric function and 45 is the angle. Okay, so inverse trigonometric function, this is sine inverse. Don't call it as sine raised to minus 1, it's sine inverse. Okay, so when I say sine inverse, it is inverse trigonometric function. Inverse trigonometric function always holds a value, not an angle. Okay, so sine inverse of any value will give you an angle. But then in trigonometric functions, sine of angle, any angle will give you a value. Fine. So that is how it is. So inverse trigonometric functions. So there are six trigonometric functions, six basic trigonometric functions. So naturally there are six inverse trigonometric functions. Fine. So let us understand this in detail. The first thing that you need to understand is domain and range of inverse trigonometric functions. Okay, so I'll write domain over here and I'll write range over here. Y is equal to sine inverse x. Y is equal to cos inverse x. So x is the value and y is the angle. So it is also called as the principal value. It is also called as the principal value. So the domain, that is the value of the trigonometric function, that is x. Okay, here it will lie between minus 1 and 1. Here it will lie between minus 1 and 1. And the range, it will be between minus pi by 2 to pi by 2. Okay, for sine, and for cos inverse, it will be 0 to pi. It will be 0 to pi. So this is the domain and range for sine and cos. Okay, then tan and cot. So domain and range for tan inverse of x and cot inverse of x. So domain is over here and range is over here. Okay, so x belongs to all real numbers for both tan and cot. Okay, the range of tan inverse x is y, that is the angle, lies between minus pi by 2 to pi by 2. So there is no equal to over here, it's only less than. Okay, and for cot inverse x, it is between 0 to pi. Okay, for sine inverse, cos inverse, we had equal to over here, but then that does not happen with tan inverse and cot inverse. There is no equal to. The domain and range of sec inverse x and cosec inverse x. Okay, so x is greater than or equal to 1 or x is less than or equal to minus 1. Here also x is greater than or equal to 1 or x is less than or equal to minus 1. Fine. And the range, that is the angle, y will lie between 0 to pi. Y will lie between 0 to pi. Pi is inclusive and here y cannot be pi by 2. Y cannot be pi by 2. Okay. And for cosec inverse x, y is lying between minus pi by 2 to pi by 2. And here y cannot be 0. So this you need to remember the domain and range individually. Fine. Okay, now some basic formulae. Uh, Sine inverse of x plus cos inverse of x equal to pi by 2. tan inverse of x plus cot inverse of x is equal to pi by 2. Sec inverse of x plus cosec inverse of x is equal to pi by 2. Okay, so this you need to remember. Next, sine inverse of minus x is minus sine inverse x. Cos inverse of minus x is pi minus cos inverse of x. And tan inverse of minus x is minus tan inverse of x. Okay, next. Now, this is not a formula, but then this is a concept that you need to understand. Sine of sine inverse of x, sine and sine inverse will get cancelled, will be left with x. And this is true for any trigonometric function. Similarly, sine of sine inverse x by 2 will be x by 2. Sine of sine inverse of 2x, it will be 2x. Okay, so it will be TF and ITF which are besides each other. Now we can send the ITF outside and sine of maybe some value theta. Okay, so sine inverse and sine can get cancelled. Now where it cannot get cancelled, that also I will tell you. Okay, so sine of 2 sine inverse of x. So in this case, we cannot cancel sine and sine inverse because along with the trigonometric function and ITF, there is a constant over here just before the ITF. Okay. See, had it been sine inverse of 2x, we could have cancelled. But then this is 2 sine inverse x. So here we cannot cancel sine and sine inverse. Of sine inverse of x, the whole upon 2. Now here also it is impossible. It's not really possible for us to cancel sine and sine inverse because there is a 2 down. So it's a constant. Okay. So there should be a pure TF and a pure ITF inside or outside or vice versa. Okay. So it should not have any other value or any function along with it within the bracket. Okay. So if it's not there, then we can cancel. But then if it's there, we cannot cancel. So, fine. Then let us go to the next formula list. A very important formula. 2 tan inverse x is equal to sine inverse of 2x upon 1 plus x square. 2 tan inverse of x is equal to cos inverse of 1 minus x square, 1 plus x square. 2 tan inverse of x is tan inverse of 2x upon 1 minus x square. Okay. So this you need to remember. Then sine inverse of x is equal to cos inverse of root 1 minus x square. Cos inverse of x is equal to sine inverse of root 1 minus x square. Okay. Sine to cos and cos to sine. This also you can remember, or you should rather remember. Next one. 3 sine inverse of x is sine inverse of 3x minus 4x cube. 3 cos inverse of x is equal to cos inverse of 4x cube minus 3x. 4x cube minus 3x. 3 tan inverse of x. Tan inverse of 3x minus x cube 1 minus 3x square. Now this might seem to be a triple angle formula, but then the format is same somewhat, but then it's not really triple angle. It's a ITF formula for 3 sine inverse, 3 cos inverse, 3 tan inverse. Okay. Next, sine inverse of x plus sine inverse of y. This is sine inverse of x root 1 minus y square plus y root 1 minus x square, sine inverse of x minus sine inverse of y, sine inverse of x root 1 minus y square minus y root 1 minus x square, cos inverse of x plus cos inverse of y, cos inverse of xy plus root of 1 minus x square 1 minus y square, cos inverse of x minus cos inverse of y is cos inverse of x into y plus root of 1 minus x square 1 minus y square. Okay. So the next formula list is quite important. Okay. So it is tan inverse of x plus tan inverse of y. So this is equal to tan inverse of x plus y 1 minus xy. Now this is true when x into y is lesser than 1. Okay. Now there are two special cases for this. There are two special cases, special case 1 and special case 2. So the above formula can be written in some other format also depending upon the values of x and y. So the first special case, tan inverse of x plus tan inverse of y is equal to pi plus tan inverse of x plus y 1 minus xy. Okay. X is greater than 0. The conditions over here are x is greater than 0, y greater than 0, x into y greater than 1. Okay. And the second special case is tan inverse of x plus tan inverse of y is equal to minus y plus tan inverse of x plus y 1 minus x into y. X is lesser than 0, y is lesser than 0, x into y is greater than 1. So when to apply the general formula written right at the top and when to apply special cases, that depends on the values of x and y. So always analyze the uh, special cases first. If that is not really applicable, then only apply the general formula, which is written right at the beginning. Okay. And 99% of the problems, will be using the general formula. Similarly for tan inverse x minus tan inverse y. So tan inverse x minus tan inverse y is equal to tan inverse x minus y 1 plus xy. Here x into y is less than is greater than minus 1 is greater than minus 1 is the condition. Okay. This is the general formula for tan inverse x minus tan inverse y. Fine. Now the special case over here. There are two special cases. Tan inverse x minus tan inverse y equal to pi plus tan inverse of x minus y 1 plus xy. Okay. And the conditions over here are x is greater than 0, y is lesser than 0, x into y is lesser than minus 1. And the second condition and the second special case is this, which I've written. X less than 0, y greater than 0, x into y lesser than minus 1. Okay. So here also, if the special cases fail, we use the general formula which is written at the top. But then more or less for every problem of this category, almost 95%, 98% of the problems will be using the general formula and not the special cases which are written down. Okay. So this completes the entire formula list that is required for TF and ITF. Now this formula list is also important for the other chapters as well as specified to you all earlier. Okay, thank you.